Here is our project title as a system for monitoring, alerting, and actuating in a distributed to centralized smart city built on the Azure IoT Central application. The main idea or goal of our project is to optimize city functions and promote economic growth while also improving quality of life for citizens by using smart technologies and data analysis. This is a comprehensive solution that enables cities to collect, analyze, and respond to data generated from various sources across the city in real time. This system is also provide a centralized platform for managing smart city infrastructure while emerging the power of Azure IoT Central application. In this project, we are using hardware components like ultrasonic sensor, IR sensor, DHT22 sensor, Raspberry Pi, connecting wires, etc. Here, Raspberry Pi 3 model is commonly used for wide range of projects including media centers, game consoles, home automation systems, and robotics. It runs on a variety of operating systems including Raspbian, Ubuntu, and Windows 10 IoT Core. Here, this Raspberry Pi is used to interface the devices like sensors and also the central application to push the sensors data into the Azure cloud. Another component is ultrasonic sensor. It is a device that detects an object and measures the distance to it. It measures the distance by emitting ultrasound and receiving the wave that the object reflects. Another sensor, IR sensor, it detects the presence of people and objects within its range by sensing the heat they emit. These IR sensors include five essential parts like IR transmitter, receiver, operational amplifier, trimmer part, and output LED. DHT22 sensor, it is a temperature and humidity sensor. It is used to sense the temperature and humidity. It has a measuring range of 0 to 100% relative humidity and 40 to 80% of 80 degrees Celsius for temperature. It has a one wire interface, which means it requires only one data line to communicate with microcontroller. Here is our working model. We connected the sensors to Raspberry Pi and also we interface the central application through it. Now for the data deployment, we use the IoT central application through Microsoft Azure Cloud Platform. Firstly, we created the Azure account using the credentials like username and password, and we logged into the Azure portal by using above credentials. After logging into the portal, we selected the IoT central application. Through it, we created a resource group. In the resource group, we again created a resource and we filled the required details. Then we created it. After creating, we deployed the resources. After successful deployment, we use the application URL to open the devices page to create the devices, device templates, etc. After opening the devices page, we created the device template. Then we opened the custom model. We added the capabilities that we required. After that, we generalized the default views. After doing this, we assigned the device template to the devices we created. Then we saved and published them. After that, we opened the devices that we are created. Then we can see the device scope, ID scope. If we want, we can change the device ID and scope ID. After that, we created. Firstly, install the VNC server. After successful installation, we can start the VNC server in our desktop. To connect the VNC server to our desktop, we need a VNC viewer program which we can download from the website. Once the VNC program is downloaded, we can enter the IP address of our Raspberry Pi, which we can get from our Fing app. After entering the IP address, then we can enter the credentials like password and user ID. After that, we can connect the Raspberry Pi and VNC viewer through the desktop. After connecting VNC server and Raspberry Pi, we can see a page from where we can see all our programs. From that, we can open our saved program. After that, copy the device ID, scope ID, primary key, and model ID from the devices page in the application page and paste them in the code which we have saved. Bring the IDs which we are copied, save the code and run. Output values in the console, what we have predefined for the sensors in the devices page. After that, we have to connect the devices to the VNC server in the application page so that we can see the dashboards in the overview where we can see the output values in the graphical representation. If we want, we can change the graphical representation from where we can see different types of graphical representations like bar chart, pie chart, heat map, etc. Finally, by utilizing IoT sensors devices, the system can gather real-time data on various aspects of smart city and it provides sufficient benefits to the needs of the citizens.